Now let me go through. Um, this is how I plan to make some much more robust bearings than the ball bearings. So I found out that really small ball bearings, like the 1 millimeter by 3 millimeter by 1 millimeter ball bearing I bought, which is super super tiny, um, which I actually have right here. Here's my 2 by 5 by 2.5 ball bearings. There they are. That's 2 millimeters width by 5 millimeters diameter. You can see next to my thumbnail how big they are. By 2.5 millimeters width. 2 millimeters is the size of the center hole, I believe. But then the really crazy ball bearings is these 1 millimeter by 3 millimeter by 1 millimeter. Look next to my thumb. These are so small, and they're like only like, I think it was like 9 cents each. Super cheap, super cheap. But one problem with these bearings, ball bearings, is this. I think these ones, the 1 by 3 by 1, can only handle like 10 pounds of weight put on them. But we're going to need way more pounds of weight for a lot of stuff in the robot. So though they're small, which is good for miniaturization, to be able to fit a lot of them in the robot, we cannot put much weight on them. But what I realized is that when you first start out on the Archimedes pulley system, which is here, the first turn or two is still high speed, low torque. But as it down gears more and more, by about, like this one doubles the first one doubles the torque, second one quadruple, this one 8x the torque. So let's say you're only pulling like 3 pounds on the first one, maybe only 2 pounds. This one will be 4 pounds of weight is being put onto this one because it's starting to get higher torque, lower speed on this one. And then for this one, this has got now 8 pounds of force put on it. This has got to be able to handle 8 pounds. Now those little 1 by 3 by 1 ball bearings can handle up to 10 pounds. So that's about where they stop. So whatever these ones are, plus these first few can be those. But I'll have to bump up to the 2 by 5 by 2.5 ball bearing for this one, since he can handle like 20-25 pounds. So this one will be 16 pounds. This one will be 32 pounds. So by this point, for these last two, 32 and 64 pound ones, he will have to switch to plain bearings instead of ball bearings. Now, a plain bearing is basically, it's metal on metal grinding. It's a tube within a tube. It's got no balls. So it's just sliding. It's like a bushing over a bushing. And it's super robust because there's no stainless steel bearing balls to crush. Basically, by having two tubes, the outer tube is called the outer race for a bearing, and then the inner tube is called the inner race. So the outer tube, or the outer race, rotates over the inner race, and usually that's separated by balls or by pins, because there's pin type bearings and ball type bearings. And then those balls just roll as the outer and inner races twist. So the race will be twisting and those balls are rolling in between. But when you need it to be more robust, because it's carrying a lot of weight and those tiny little balls aren't able to handle much weight on them, you then need it just to be a plain bearing. So no more ball bearing. Now this is going to increase friction, but greatly increase the amount of load its load carrying capacity. It will be way stronger. It can handle the heavier load. So I was like, okay, I want like 5 millimeter OD, and then a tube to go in that. Let's say the wall thickness of the outer one, the 5 millimeter OD, let's say the wall thickness is like 1 millimeter. Then the tube that goes inside that would be like a 3 millimeter OD tube. And And I was like, huh, could I make that by like cutting out nickel strips with scissors and drilling little holes and stuff? Could I like fabricate this and spot weld it together in layers to build it out? I was like, I maybe could make one without like needing a lathe or something. But then I was like, wait, what if I could buy tubes? So then I looked up tubes with the dimensions I wanted, and I found you can buy them. And I found like the perfect size tubes. So I can make my bearings so easily with basic tools. So check it out. This is a 5mm OD stainless steel tube with 0.8mm walls. And look what I got inside it, boys. It's like a perfect fit. I bought 3mm OD tube that goes right in. And so that would be the basic operating principle of a plain bearing. There's barely any friction, and it slides all around. Super smooth, super awesome. Now, obviously, this would be like the widest bearing ever. So we don't want, it's 300mm long, but we only want our bearings to be about 2 or like 1.5mm in thickness. So we would cut it like like a loaf of bread. We would cut. We need to make a bunch of cuts. And to do that, I was thinking of making a Dremel table, or no, what's it called? You know the table where like you put your hand on it and you put the piece of wood and you like slide it forward, and there's like a wheel on the table that's cutting, and you like push your wood onto it, but you don't want to cut your finger off, but you like push wood and it cuts it. What's that called? Like a saw table? I wanted to make a mini saw table with a Dremel diamond spinning wheel on it, and then we would be able to like go and cut this, and it would cut like the perfect amount. So that's how I'm thinking of doing it. But I was wondering, like, can I outsource that? Could I like send some machinist these two parts, and they like do the cuts to cut it into like 100 little bearing pieces, and then I assemble it, grease it, and then like make it into a pulley like we showed before. So I'm thinking about that. And look at this. So the first one, like I said, it's 5mm OD, 0.8mm wall thickness. But I could also go with the 1mm wall thickness. If you do 1mm wall thickness but 5mm OD, that would mean the center hole is exactly 3mm. This is 3mm OD. So that would be like an exact fit. But I went with 0.8mm wall thickness so that there would be a 0.2mm space to fit this in easily. So that's what this one is. But I also bought the 1mm wall thickness 5mm OD for this one, which wouldn't let this fit. But if we sanded this one down a little bit by hand, it would get the tolerance to be able to fit in here. And we'd only have to remove like, I'm not a machinist, but they say like 5 thou. I'll remove 5 thou from it. Trying to talk all fancy. So it's like 5 thousandths of an inch you'd remove. So that, I'm guessing you just take like some, I don't know, like 100 grit sandpaper and just like rub it around like this, like you're cleaning copper pipe before you solder, like plumbers. You just rub it around and then you just test it. Does it fit? No. Just rub it around a little bit more. Does it fit? Yes. And then you make your cut, and then you make your cut, and then you just assemble, and then you've got your plain bearing, which will be perfect snug fit. Now I don't know what the tolerance should be. How much slop should there be between the inner and outer one? ChatGPT was saying like it should be pretty snug, and it was saying like 0.2 of a millimeter is like too much slop. Like I can move this around. It's kind of slop. I've got a decent amount of slop. And it was saying like that slop will like not be good. But I'm thinking like, well, doesn't that slop leave more room for a little bit of grease to fit in there and stay in there to keep it lubricated better? I'm not sure. I'm not a machinist. I'm gonna have to ask ChatGPT more about that. Or like have somebody chime in that knows about this type of stuff. But this was a super cheap way to do it because each one of these is like $8 or $9, and I'm able to make like hundreds of little pulleys from this. So that'll come down to like 2 or 3 cents per pulley. So that's really good, and that's the way I can make plain bearings, pulleys, plain bearing pulleys, as opposed to ball bearings. So that's a cool breakthrough, and that's some of my thoughts. I thought about like trying to have the outer race and inner race made by JLC PCB, but then I don't know if they will have that level of precision of tiny stuff. They were saying like their precision you can set is only medium or point plus or minus 0.05 millimeters. That's a little bit too sloppy, I think. Maybe that's precise enough. I don't know. Do you guys think that's too sloppy or precise enough? I'm not sure. Um, and do I want them to be making this from scratch, or would I want them to start out with a tube like this? Would they know to start with a tube like that? Would I talk to them and get a discount if they're like, oh yeah, we can just cut your tube, that'll be easy, instead of them thinking like, oh, we have to start from a big cylinder of aluminum and like shave it down with our lathe, and then like make the cut and put the center hole through it. And they're thinking that's a lot of work, but I'm like, no, you could just buy a stainless steel tube and just do the cuts. And there's another thing. I had a guy on Reddit offer to do CNC or like metalworking for me, and he said, because he thought my robot project's so cool, he said he'll do it for free. I just pay the material costs. And he was like, you know what? On second thought, as long as it's not titanium or something crazy, I'll even pay the material costs. Just let me know. And I told him thank you, but I don't know if I'll need that. But maybe I could reach out to that guy on Reddit and say like, hey, are you still willing to help me with that? Maybe he would do it. So I don't know. I'm asking around for suggestions on this particular set of challenges or what have you. Okay. Yeah, it's going to definitely have lubricant. Um, I'm going to be adding. Actually, the ball bearings I bought don't have any lubricant, and neither, obviously, do the plain bearings because I haven't even made the bearing yet. I'll be using silicone-based lubricant. Basically, I have some silicone spray, aerosol silicone in a can. I was thinking of just spraying it with that. ChatGPT said you need like a very, for like very small bearings like this, you don't want a thick lubricant like you'd use on a wheel bearing for a car. It says you need like very thin viscosity lubricant, and preferably silicone based. It was pushing on me, and so I was like, well, could I use this ChatGPT? Could I use spray silicone? It was like, yeah, that should be fine. So I'm kind of leaning that route. Okay. So I don't know if I'll have it. I thought about trying to make the bearing outer and inner races 3D printed with a metal 3D printer that does sintering by JLC PCB doing that for me to make them. But then I think like it's $8 as like their minimum cost for a print, just to even do the print. I'm not going to pay $8 for the outer race, $8 for the inner race. That's $16 for one bearing, and I need it'd be 2 plain bearings per motor per direction of the motor. So that's 4 plain bearings per motor times 300 motors, 1,200 bearings at $16 a bearing. That'd be like $18,000. I'm not paying that. Whereas it'd be like just pennies to make the bearings myself using tubing that's already ready to go. Okay. So I'm definitely not going to have them laser printed, laser sintering 3D printer. But I didn't know if having them CNC it would work. I'm not sure. What do you guys think about like me sending some machinist like this and having him cut it out? Should I do that, or is that being lazy? Like, just cut it out yourself. I don't know, like, if they would do it for like $15, $20, $25 to cut these out. Maybe 25 would be fair. Maybe 30. Would somebody cut these into like 100 little slices for $30? I don't know. I don't know if anybody would. I don't know, man. How much am I willing to spend on the robot? It's so foreign to me to like pay other. Every time I pay other people to do my own work, I regret it. It's either like I should have just done that myself. I could have saved money, or it's like I could have done a better job and learned those skills, which I want anyways. So I'm always kicking myself if I do it. It always comes back to bite me. Like I used to pay people on Upwork.com to do my 3D modeling work for inventions and stuff, for prototyping and whatever. And then I'd have to work with them so much, like, no, you got to do this, no, fix this, and then like I realized like if I just relearned how to do 3D modeling myself, I would be able to do everything faster by not having to go back and forth with these people trying to explain what to do. And I'd have it done immediately. I wouldn't have to like find a worker, work out an agreement, do a agreement, and figure out the pricing, come to an agreement. All that stuff is extra time lost. I could have just been making it. So it's just tough, guys. It's tough paying other people to do my stuff.